Getting all. Yeah, welcome to the session. The first lecture, which is on basics of TOC. In the previous lecture, which was introduction, like how we are going to start the TOC and what is the importance of TOC, what was the weightage of TOC in GATE exam. And today is the first and most important session for the theory of computation. Like you study any subject, there is something should be learned before starting the subject. So today is the session which will help you to uh, understand the foundation or basics of theory of computation. And those people who are not aware of the Telegram group of mine, you can join my Telegram group and parallel you can start discussing. If you have any doubt related to this, you can discuss on Telegram or you can discuss on even YT chat. Have both options, but you know YT chat is always delayed, so you can directly discuss on Telegram chat too. Good evening. If you have joined, you can also say good evening and hi on Telegram too. Good evening, Mamta, Astosh, Jai. Good evening all. And also, if you are not aware of about me, my name is Mallesham Devasane. People call me as Devasar, and I did MTech from IIT Bombay and have 10 years of teaching experience and nearly 2 lakhs GATE aspirants I have guided so far. I'm still counting on it. And what is today's agenda? As you know, if you want to learn TOC, the first important topic here is to learn what is this set, and second, once you learn the set, then we will learn symbol, string, and for TOC you need two important things. One is alphabet, other is language. These two are actually sets only, but these two will give you an importance of how do you solve the problems, how do you represent the problems, right? And symbol and string are just basics, but once you start TOC, you will always worry about alphabet and language. What is your given alphabet and what language you are forming? Okay, these two things are going to be important, right? Now you will get to know what is Chomsky hierarchy talking about. Yes, the last session I was talking about Chomsky hierarchy, but today I'll disclose more in detail about Chomsky hierarchy. Got it? The first very important definition is a set, right? Here we use the word alphabet language. How many of you know there are also actually sets only? Are you aware of that? And people do not know about it. Please know alphabet is also a set, language is also a set. We are going to learn two kinds of sets in the representation. Okay, let's start with the set, and today's agenda is clearly described here. And the first we learn set, and knowing about set is very important to begin with the TOC. And then the symbol is the very smallest block that we start representing strings and language, everything about, right? String is basically sequence of symbols. We'll talk about it. And alphabet and language are the two reasons why we study TOC, okay, to represent the problems, to solve the problems. Aditya. So meanwhile, if you have any doubt, please use this Telegram QR code to join my Telegram group and start discussing the doubts too. This is during the live session, or even if after the class also, if you are watching recorded, you can also join group and ask the doubts. Okay, let's start with this set. Okay, it's a mathematical set, right? Set basically is a collection. Everybody agree? Collection of objects, collection of anything. And what kind of objects you will collect? When you collect, you will always represent in a bracket, correct? That's called as collection of objects. How many objects are there is your choice. Will you keep finite or infinite? That's your choice. There are two types of collections, finite collection and infinite collection. Now when you are going to form a collection, then remember, if I have, let's say 2, can I write it 2 again? You can't. So anything you write here is definitely distinct, right? The objects must be distinct. You cannot repeat object. Like I cannot write 2 comma 2 in a set. Everybody, you can't write. That's, if you write it, it is called as the multi-set, not a set. Okay, that's a different definition that you get. If anybody writes 2 twice, it's not going to be set. You will have a different definition for that. It's the multi-set. But we are basically studying the set. Usually we use most of the applications. So collection of the distinct objects, well-defined objects. Everybody knows collection of distinct objects means each element is unique and not repeated. As the most important word we use, a distinct. And there are 2 types of objects. Cardinality, either defined or not defined, depends on 2 types. The number of objects, when you look at, either they are finite collection or infinite collection. I can have 2 types of sets. I can write 1, 3, something like, right, 5, 9. This is finite collection. If I have infinite collection, I can say x such that x belongs to n and x greater than 5. So this collection is infinite collection because every x which is in natural set and greater than 5 will appear here, like 6, 7, 8. And I cannot represent as a set because I can't list all the elements here. So we need to use a set builder notation, right? There are 2 ways to define. Either you list or you make a rule. And basically when it is infinite set, you need to build a rule to form an infinite set. And when you have a lot of elements in a set, then always set builder is going to help you. If few elements are there, you can list out, but if there are 100,000 elements, rather than writing, you can represent as a rule. Now, so why we need to study this set? You might have a doubt. In whole TOC, there is always a confusion when somebody writes something like this. Correct? This notation is not going to be easy for many students, and I have seen myself when I discuss the concepts during the sessions, they do not understand what they are trying to say, right? And the way you study is, we should keep every x in this set. Yes or no? We should keep every x in this set. And what kind of x you have to keep? That x has to be belongs to n and x should be greater than 5. When you apply these 2 conditions on this form, this is the form of a string, and you can assume this is a condition 1, this is a condition 2. In this form, you apply these 2 conditions and you will get x is equal to 6, 7, 8 and 9, likewise all of them, and every x you have to keep in the set. That's why you get 6, 7, 8, 9, everything. It's not about 1 or 2x, it's about the way you speak is every x which satisfies the two conditions. Okay, every x satisfies the two conditions you should keep in the set. Okay. Are you able to understand? So this is why set basics are very important for theory of computation. I don't know how many of you know the way that you are studying, as I explained right now, the many people, they're not able to form because they don't understand the definition of the set builder. So I hope you understood now what is the set form or formation or collection of objects. Able to understand? So can we practice some of them? Okay, please help me. What is this? X such that x belongs to n and x greater than 3 and x less than 10 and x not equal to 7. Can you tell me what are the objects are going to come in the set quickly, either in the Telegram or in the YT? So please answer the first question. Which will give you basic foundation of the theory of computation, because we are going to write a lot of rules like this in our theory of computation. But instead of x we write a w or something else which forms a string. And please like the session and also share with your friends who wanted to learn theory of computation. And great. 4, 5, 6, 8, 9. Now first thing is you need to look at a natural set, and in that you will have 1 to infinite, and now x should be greater than 3, so you should start from 4, and max is 9, so 4 to 9, but it should not be 7. So what will you get? 4, 5, 6, and it should not be 7, so we'll have 8 and 9. Everybody understood? Now my question is, can I write is equal to 4? Yes or no? That's it. This is where we will understand how you are learning the basics. If somebody says the option A like this, option A 4, option B 5, 8, option C 7, 9. Okay, I'm only giving. Is it correct? Is there any option matches here? Go ahead, go ahead. Right. No, right? Never choose the partial answers, right? Okay. So this is where you need to focus on, and half of the elements you should not keep. You should keep all the elements of the set which satisfy the conditions. So in TOC, when somebody asks the question and people choose off of the strings, that makes their answer is wrong. Everybody clear? So no answer should be chosen from here. Only the answer you should choose, that 4, 5, 6, 8, 9. X such that x belongs to 0, 1, 3, 5, 9, where x is greater than 2. Now will you focus entire world or will you focus on the given condition only? Only given condition. Now this is where x belongs to. and what is the value of x should start from. That greater than 2 means should start from 3. Your answer will be waiting for your answer because it takes time in YouTube streaming, so I will wait for a few seconds. Everybody got? Your focus is only on the given the domain. This domain is x belongs to this domain and x should be greater than 2. So you can satisfy only 3, 5, 9. So in TOC, this kind of observation is very, very important. Your focus always, remember that when somebody asks you, here put this, there is something here, it is a form of the string, and either they will write a bar or they will put a colon that represent such that, and they will put some conditions. We don't know how many conditions they will write, and they might have multiple conditions too. Sometimes they write C3 or C4, something like that. Then you must satisfy this comma represent and. If you want to write or, then write C3 or C4 as a one condition. Correct? The comma represent basically here and. Now this form is your member of the set. In this set you are going to keep this, and this form should satisfy all these 3 conditions. Correct? And when you have or, then you can satisfy any one of them. Able to understand? The whole TOC, when you form a language or when you form any set, then focus on it. What is your given form? If they give you W, focus on W. If they give you WX, focus on together, not just W. Remember, the form always important, whether it's W, WX, your form should be, you must take entire thing. W is not considered as a form now. WX is your string form, your object form. Okay. So always look at what is given here. Never assume W is a string is a wrong sentence. It's only sometimes, right? Only sometimes when you write a W, it is the right thing. Right? If I write only W, yes, your string looks like the W form. But here you may not write a W all the time. I may write AW. That means AW is your string form. Okay. So keep observing your form, and that's where you stand, how you convert the basics into your TOC. I hope you got a clarity like what is a set. You study more in detail in discrete mathematics, but I just want a what is a set. Set is the collection of objects, and do not repeat any object twice because all are distinct. 3 I should not write it twice here. Now, in a TOC basics, the first important, so far mathematical concept I was using, right? So far I was using mathematical concept, the symbol and symbol, alphabet are the same or different? Anybody? I have seen a lot of people who are teaching, who are learning, are the same or different? Okay. You can also answer on Telegram wherever you are there. They are not same, they are different. Everybody clear? Alphabet basically called as a set. What is it? A set of symbols. That means you must write a bracket and keep some objects here. This is what alphabet. And symbol is not a set, right? It's anything in the world which you want it as a basic thing. So what is the symbol? What is a symbol? It is smallest unit. You can say smallest block, right? we can call it as it is one length whatever you write it. If anybody says it is a symbol, like example, AA is a symbol, is it one length or two length? AA is a symbol, is it a one length or two length? When somebody says AA is a symbol, is it a one length or two length? Look at a chart. No, it is one length. Anytime they call a symbol, it represents one length. This is what you require in TOC. Never be two length. When AA is two length, if A is a symbol, then AA, if you want to know, is a two length, because symbol always corresponds to one length, one length. Here when I say AA is a symbol, symbol means one length. Everybody? The definition itself says I am the one length. And never misunderstand English and the computation. Computation has the basics, and in a computation, if we call something is a symbol, that thing is the one length. If I say gate is a symbol, then what is the length of the gate? Is just one. A symbol definition means a one length. You cannot say two length, four length, all this. When will you consider this as a four length? If G, A, T, E are four different symbols, then this will be considered as a four count. Everybody clear these things? Anytime somebody calling something is a symbol, that is always considered as one length. Right? The first most important definition in TOC, people call it as a symbol because to assume it is a one length. You know A is there in English language, but if they are creating their own language, AA might be their symbol and single A may not have a meaning to them. Then AA must be considered as a symbol. You studied English language, that's why you know A is the symbol. But if I did not study English, directly I am studying this language, they say AA is a symbol, I should assume AA is the one, not a two. Is that clear? So TOC talks about everything in the world. There is no restriction which domain you apply these concepts. So if you just blindly assume they are English letters, you are wrong. They might be defining their own language. For them, gate should be just one, not four characters for them. Okay, that's what I'm going to help you. What is a symbol? First focus is a symbol is always the smallest thing in the world, which is one length. Done? Now, once we know the symbol, then people talks about the string, right? And using the symbol, people first form alphabet. Alphabet, you know, people can represent with the different notations: sigma, delta, gamma, tau, A, B, C. Is your choice. Notation has no restriction in the world. But people study like in TOC, if you want a sigma, they will call input alphabet. In entire, you know, TOC we use this notation, but not limited to sigma. In exam, they may use any notation. You know, this we use study in sometimes for output alphabet, because to collect all output symbols. And gamma we use for the stack alphabet to collect all the stack symbols. And tau, these are the very famous notations in our TOC, the tape alphabet, to collect all the tape symbols. At alphabet could be denoted with any notation. Mostly we use the uppercase or some different notations. Okay. So alphabet is first thing is it is a set. Everybody believes? Any alphabet you take, it is just a set. What it contains? It is a collection or set. It is a set of all symbols. But how many symbols are there? It is a finite set. You cannot write infinite set, like it is a finite set which has only finite number of symbols. Okay. You cannot write infinite symbols in the sigma, because sigma is the source of a language. If you want to form a language, first you should learn symbols. Example, if you want to learn English language, how many letters are there? How many symbols are there in English alphabet? In English alphabet, like English alphabet, if you learn it, it has only A to Z, maybe uppercase also, 26 plus 26 you have it. These are English symbols that we read, A to Z, 26 plus 26, lowercase and uppercase together. If you are learning numbers, like if you are learning binary alphabet, binary language you want to form, then you will use only 0 and 1, like digital logic we use, right? Boolean alphabet, Boolean we use true or false only. Similar to binary alphabet, we use here true or false. Like you have a decimal alphabet, decimal you require the 10 symbols total. Those 10 symbols are 0 to 9. Like you will have ternary alphabet, octal alphabet, hexadecimal alphabet. Is there any limitation to form an alphabet? Is there any limitation to form alphabet in the world? You can form different alphabets in the world. There are infinite possibilities, but each alphabet will contain only finite collection, right? If anybody asks, what is the size of the alphabet in the world? What is the size of the alphabet? The alphabet is a technical word, and any language that you frame over the alphabet, first alphabet size is always finite. It's impossible to have an infinite alphabet. If you have it, then learning the language is not easy. Like you learn any language basically that is well framed, could be binary language, C language, C++, Java, English language, Hindi language, Telugu, Marathi, Tamil, right, Malayalam, Kannada, go for anything, any specific language in India or abroad, right? They definitely have the alphabet size is finite. So everyone who is learning that language, first they start with alphabet. Once they learn all the letters or all the symbols, then they will frame the words. Words we call as strings here, and then once we form once we understand the words, then we will start framing the sentence. Okay, that's how it happens. And any doubt during alphabet about alphabet? The alphabet is one of the most important one. See, it is a set of all symbols. It is nothing but it is set of all one lengths. Can I say that? Whatever you are keeping in the sigma or in any alphabet, it's just one length. Doesn't matter what I put here. If you write somebody like sigma is alphabet, if I am writing A comma BB, can someone tell me what is the size of A, what is the size of B? B. Can someone tell me? Because here this is considered as a symbol. Any symbol that you consider, it is just one length. No matter what I write, you can always convert to something else, x comma y, because you are confusing here. You can assume x is A, y is double B, then you can frame over x, y. Finally, you can substitute what x and y you assumed. Okay? Both are one only. But here we can form a lot of strings. Before that, let me help you over the sigma. If I write a sigma is equal to A comma B, then what is A length and B length here? A is one length, B is 1 length, but if anybody want double B here, it is going to be 2 length. Here the single B has no meaning. Yes or no? B has no meaning in this alphabet. Only double B has a meaning. Meaning of 1 length. So you should know there is no single B here. Only we have the double B. Anytime you write, you can write only double B at a time. Here you have a single B, meaning if you want a double B, you have to repeat the B twice. So you get a 1 length followed by 1 length, you will get a 2 length. Here double B has a meaning, single B has a meaning, but single B is a symbol, but double B is not a symbol here. Everybody agree? Double B is not a symbol. What is it? Sequence of symbols. It is a string, because you are forming this by repeating a symbols. It is a sequence of symbols, not a one symbol. Here double B is a symbol and B has no meaning here. Understood the difference between the two different alphabets? And if you are using Telegram, you can use this my group, and you can also reply there, so that you will be connected with me even after the class. I hope everybody knows now alphabet. We'll discuss more about alphabet soon. And now we'll go for the strings over alphabet. That means without alphabet, can you form a strings? Without alphabet, can you form the strings? Like without knowing English letters, can you learn English words? Without knowing the binary symbols, can you form a binary number? Without knowing the C character set, can you write a C tokens? Not possible, right? Maybe you learn one or few, but you can't understand everything. And whenever you write strings, you should know what alphabet you are considering. So now I'm considering one alphabet which is very famous in our exams and textbooks, that is A comma B. And if I'm writing A comma B, all your strings should depend on only the two symbols A and B. There is no C, there is no D, there is no E, there is no F. Everyone, you can focus on only two symbols A and B. That's all. Anything you form, you must use these two symbols, nobody else. This is what a restriction. Before forming a language, why we need alphabet? Because this alphabet is going to restrict you. Anything you write, you can use only these two things to repeat. Now, when you form a strings, there are so many types of strings. You can form zero length strings. This is not there in English. This is not there in most of the applications, but some of the applications may require even zero length also. Okay? And zero length strings are only one, so you can write zero length string. And one length strings, also called as symbols. One length strings is also called as basically symbols. And two length strings, that means symbol you should repeat 2 times. And 3 length strings, and so on. And there is a notation for it. When you want zero length string, you can write as a notation is equal to sigma power 0 is equal to sigma power 1 is equal to sigma power 2. That sigma you can write sigma square. You are repeating sigma twice. And sigma, when you write 3 times, you will get sigma power 3. You can also say sigma square, sigma power 1, or sigma power 1, sigma square, so on. Correct? And what is sigma power 0? Right? Zero length string is just here epsilon. Here you will have A and B you can collect. In 2 lengths you can have AA, AB, BA, BB. Means I can repeat the symbol twice, but any 2 symbols you can take and put together in a sequence. Here you can have repeat 3 times. In 3 times you can keep any symbol like AAA or AAB. A lot of symbols are going to be happening here. B double A, B A B, all combinations you can use to frame 3 length. Able to understand? Likewise, you can form 4 length, 5 length, 6 length, 7 length, 8 length, 9 length, 10 length, 100, 1000, 1 lakh, 1 million, 1 crore length. No restriction, right? But every time you form, your string has to be finite length. You see, the string I can't write infinite symbols. I can write infinite strings, but within a string, I can't write infinite symbols in a computation. So here, the string is only one type. Even though you have 2 types, finite length string infinite length string. How finite length, infinite length looks like? Finite length string is going to be like this, like A, B, B. Is it finite length? Because it's 3 length. 3 is the finite length, correct? And when somebody writing A, B, A, B, A, B, it's repeated infinite time. Now, what is the length? Infinite length. And is it possible to understand infinite length like real numbers basically? And we never use this such strings in our computation. So in TOC, this is not at all used in the computation, right? In practically, if you have any infinite, the real number basically, you will round it out and then use it, but you don't get actual answer. You will get approximate answer all the time. Right? That's why some of the outputs will not be accurate because of you are using real numbers. Those computation depends on real numbers. You cannot find exact answer all the time, right? Everybody? Now, my question is very simple. Every string is what type you have now? Whether it is epsilon, whether A or B, any string that you write in this world over the alphabet, it has to be finite length. But such strings, how many I can write? Infinite. Because I never stop writing it. Even the finite length like 0 length, 1 length, 2 length, 3 length, 4 length, 5 length, 6 length, 7 length, everybody is the finite. But I can write forever. Everybody got the definition of a string? But do not write a string which is of infinite length. It is not used in the computation. Like very simple example. When you have written a program, you want to give an input. If you want to give an input, can you give infinite input? Then when will the program executes and gives the output? Right? Input stop after some time. Like I will give 10 numbers or I'll give 100 numbers. Can I give infinite numbers as an input? No, right? The input always has the finite choice. And program should work for finite time and should produce an output. Otherwise, we don't need a program. There is no purpose of using the program for such things. Simple purpose I am talking about. Good. Now, the one small problem happens to the people like, sir, you said sigma is the a comma b, right? Now, let me tell you what is the difference between epsilon and a, or yeah, it's okay, b, a, b, whatever. You are able to understand all of them, right? Now, can you tell me who is a symbol in our language? At least let me tell you, here we have seen all of them, right? Who is the symbol here? Is that epsilon symbol or a symbol, b symbol, double ab is a symbol? Who is the symbol among these 4? Very, very basics, and you really need them to understand the TOC. Don't ignore the words we use: symbol, string, language, and set. Very important to learn the TOC. Today's topic is fundamental and foundation for your subject. I've given all the 4 columns. Who is the symbol? No, epsilon is not a symbol, AAB is not a symbol, only these 2 are symbols. Read the definition. This is a set of symbols. Can you see epsilon here? And only symbols that you have, A is a symbol and B is a symbol. Anybody else you see the symbol? Epsilon, is it there in the sigma? Epsilon is might be the symbol in the, maybe in geeks or somebody somewhere else, right? It is not here, right? We are not learning Greek alphabet or somebody else. We are learning alphabet that is given A and B as a symbols. And by mistake, please never say epsilon is a symbol for this sigma. For this sigma, only A and B are symbols. If I give sigma is equal to epsilon comma A comma A, don't use that, B, in that case epsilon also symbol. Now epsilon is not empty string for this sigma, because you said epsilon is a symbol, then empty string should be like lambda or delta, somebody else you should use it. Everybody able to understand? The sigma decides who is the symbol, not we, right? But we should understand as per the alphabet. Here epsilon is a symbol, but here epsilon is not a symbol. And symbol definitely you will see in the sigma whatever it is given. Okay, all clear? If suppose sigma has AAB and they have written something else CDE, then now AAB is a symbol and AB has no meaning in this sigma. Everybody, if I talk about this sigma, the same 4, then AAB is a symbol because it is there in the sigma, and A and B no meaning at all. You can't speak them what are they, because they don't have a meaning. And epsilon maybe you can consider as an empty string. Okay, so sigma decides what are they. And please don't say blindly A is a symbol, epsilon is a symbol. Never. The sigma decides who is the symbol, who is the string. And now the second, string. Who is the string for the given sigma A comma B? That's why the first session is very important to know what is a symbol, string and language. What is a string? Can I call epsilon? Yes. Which string we call here? Empty string, null string, a 0 length string. Correct? Null string, empty string, 0 length string, because epsilon means nobody is there, 0 symbols is there. Okay. And is this a string? Yes, we call 1 length string. Yes, it is also 1 length string. And yes, this is 3 length string because I can repeat 3 symbols to get it. Everybody is a string here. Okay. And is anybody set here? Is anybody set here? Nobody is a set. Set means collection. Like when somebody talks about pi, let's say the empty set, people call it as a pi. Right? If you want to know about it, now I can tell you the pi is not a symbol, not a string, but I can tell you it is a set, empty set, language. Able to understand? Somebody want to know about pi. Pi is not a symbol, pi is not a string, it is a language, empty set. For the given sigma, and all this notation should be very clear for you to study the languages. Especially people confuses the epsilon 5, and epsilon is empty string and pi is what? Null set, not a null string. Empty set, not empty string. Unfortunately, we have the word called as empty here, but that is for the set, that is for the string. Okay. String, what is a string now? What is a string? When you form a string, the string is a sequence, right? What is a string? It is a sequence of symbols. Which sequence? Finite sequence. Can you write an infinite sequence? it is a finite sequence of symbols. That finite sequence means 0 sequence epsilon, 1 sequence is the symbols, 2 sequence, when you write in a sequence of 2 length, you will write 2 length string. Right. Here people call sigma power k is actually collection of set of all k length strings, because the sigma you repeat how many times? K times. Example, if I write a sigma power 0, you will get what? Epsilon, because 0 symbols when you write, you will get epsilon. If you say sigma is equal to a comma b, and sigma power 1, you will get all 1 length. When you write a sigma power 2, this is repeated twice, like sigma power 1 dot sigma power 1, which is going to give you a comma b dot a comma b. So you are going to use the concatenation, like a with a, you will get double e. A dot a means double a. A with a b, that's ab, and b with a, ba. So all the 2 lengths are going to come in the sigma power 2. Right. Now you know what happens for the remaining powers. Understood? Ultimately, we come for the language, right? That's what we wanted to learn, languages. Language over alphabet. So without alphabet, you cannot form a language here. What is a language? It is a collection. It is a set, right? But which kind of set? Of strings. The strings are defined already over the alphabet. If I take a sigma is equal to a comma b, what strings you can write? Strings I can write epsilon, a, b, double a, b, ba, bb. There are infinite strings we have, but every string is a finite length, correct? We can write infinite number of strings. Now languages. What languages you can frame in the world? Languages. Every language you must write a bracket, correct? This is called as a set. And if you don't keep anything is also fine. If you keep only one of them is also fine. Epsilon, a, like only one string also you can keep, right? Even you can keep 2 strings if you want. Likewise, you can write infinite. You can write even 3 strings, something like this. You can write even 4 strings, and you can write even infinite strings. Sometimes you may write like a power n, where n greater than or equal to 0. That means you can have all the strings by repeating s. That's infinite language basically. Infinite number of strings are there. Now languages are how many types here? Strings only one type, finite type, right? Every string you look at only finite type. But languages, how many types are there? You can write finite languages. You can also write infinite languages like this, b power n, where n greater than or equal to 10. You can also write infinite language type. So now let me tell you the difference between the symbol. Symbol is always one length no matter what you write, correct? If I write sigma is equal to something like this, a comma b comma 1 comma 2, and here how many symbols are there? Anyone? Here only 2 symbols are there. Here a comma b, you can see this comma separates 2 objects. This is called as a symbol, and if anybody asks the length of this, you will get just 1, right? You can convert this into x comma y to understand better, but whatever it is given, and even ask 1 comma 2 here, it is 1. If you want the more length, you should just repeat them. Like how do you repeat? A comma b, 1 comma 2, then the 3 times you have written a symbol, this length will become a 3. Everybody able to understand? What is a symbol? Symbol is just one length, whatever it is. Okay, that mostly you will see in the sigma. And string over alphabet. So without alphabet you can't understand your string. So string, let me tell you, the over sigma. Sigma assume alphabet or delta, gamma, whatever, and the string is always finite length, no matter, right? Finite sequence of symbols, 0 or more. And if you ask what is the string length, always the string length is in between 0 and some finite. You cannot have infinite. Everybody, you can start with 0, you can always write finite length, but you can't write infinite length. The string always finite type. Okay, the length of the string is definitely equal to finite, no matter which string you write. It could be 0, 1, 2, 3, but you can't write infinite length. You can only write the particular length always. And language over alphabet. What is the language over alphabet? It's a collection. Now there are two types of languages. You can write finite language type, or you can write infinite language type. Finite language means only finite number of strings. Infinite language means there are infinite number of strings. Just like mathematically you have finite set, infinite set, the same kind of difference. Are you able to understand? Now some questions you will have, you can answer it. I'll write a question 1. For today's topic, I'm just writing the questions. Question 1. I'll not give the answers. Please write all the answers 1, 2, 3, 4, and you can also put in the YouTube the comment section, or you can come to Telegram that I have given link. You can also post the answers. I'll cross check. Okay. Size of alphabet. I'm not saying which alphabet, but you can always answer something here. Okay. Question 2. How many languages are possible over the sigma? Question 3. How many finite languages, like finite set, exist over the sigma? How many infinite languages, because the languages are two types, right? How many three length strings over sigma is equal to A, B, C, D? So the 5 questions that you have, I hope you have noted, right? And other 5 questions I'll write here. Let sigma is equal to 𝐂𝐸, exam, and find the size of 𝐂𝐸, and find, that's a question 6, right? Question 7, use the same data here and find question 8, what is the size of empty string? Question 9, size of, the size here you can call length also, and size of empty set. And last question, how many strings, did I write that? How many strings? How many strings over sigma? Let's say equal to a comma b. How many strings exist over sigma is equal to a comma b? So I hope you will answer these questions, and as I have another class, I need to attend the regular sessions. And if you have any doubts, I am always available on Telegram group, so you can join there and you can tag me. And if you have any doubts related to GFG courses or our regular doubt session mentorship, as I promised, I'll be interacting with everyone on Telegram. If in case if you need my guidance or my suggestions, they are there to help you. Okay. All the answers please post on Telegram group. I'll be replying to you. If any answer is wrong, we can also discuss. Thank you so much for joining today's session. See you tomorrow. Jai Hind.